Looks like we've been handed a definite integral on this one. Ooh, what are we gonna do? I'm scared. I'm not, neither are you. You got this. Okay, let's factor that denominator, and then we'll just start integrating by partial fraction decomposition. And we're doing that because we can factor that denominator. It's gonna make this process much more feasible if we do it that way. So here we go. The integral, don't forget your 1 and 2. X minus 2 over, and then we're going to factor this, and you know how to factor. So 2x and 1, x and 1. I need a positive 1 in the middle, and so there we go. That's going to do it right there. Yeah, okay. So we're going to go a little further, and what we're going to do is this plus this. There we go. And one of these denominators is 2x minus 1. The other one is x plus 1, and we don't know the numerators. We can call them a and b. I will in a moment. No, I won't. I'll go ahead and leave them blank. We'll figure out what they are. So let's make up some stuff. Not make up some stuff. Let's write some stuff down. So if I was going to solve this equation, let's drop the integrals for a second. If I had x minus 2 over 2x minus 1, x plus 1, and that equaled a, we'll call it a, over 2x minus 1. Let's do that just to hold its place for a minute. I'll erase those later and put the actual numbers in its place. And then b over x plus 1. Then in order to solve this, good old-fashioned Algebra 2 style, I'm going to show the process because I feel like it. I would multiply every term by the least common denominator, which means this gets multiplied by 2x minus 1, x plus 1. This gets multiplied by 2x minus 1, x plus 1. I'm just showing you how it works. You've seen it. 2x minus 1, x plus 1. There we go. And we're going to cancel some stuff out. Those cancel, and well, everything over here cancels, which was kind of the point. And we have x minus 2 equals a times x plus 1 plus b times 2x minus 1. Okay, so again, starting all over from the very beginning, we realize, first of all, it's a definite integral, so our final answer will be numerical. It's probably going to be very irrational. It's going to involve a logarithm for sure. And, excuse me. And we are going to have to use partial fraction decomposition, which we're doing. And now we're going to just create random numbers that aren't quite so random. Let's get rid of b first so we can find a. In the process of finding a, we'd get rid of b. That would be 0. In order to do so, x would be positive, almost said negative, positive 1/2. 1/2 here would be 1 minus 1. So if x was equal to 1/2, then this is what it would look like. X is a half, so I have 1/2 minus 2. That's negative 3/2. Doing a lot in my head. And 1/2 goes here, so that'd be 1 1/2. So 3/2 times a. 3/2 times a. So a would be negative 1. Ah! Found it. A is negative 1. Okay? I'm happy if you are. Let's keep going. I want to find b next. In order to find b, a needs to go away, which means I'm going to put a negative 1 right there. So x equals negative 1. And we'll keep going. So a is negative 1. That's now gone. Negative 1 goes here. That'd give me negative 3. Negative 1 goes here, and that gives me, let's see, negative 1, that'd be negative 3b. So b is equal to 1. Ah! Now we found a, we found b, we're ready to keep going. It's 1. There we go. We're ready to keep going. So let's recap. Love that joke. Let's not recap. We've recapped once already. And as we move on, we're going to be integrating, and again, definite integral. So moving on from here, we have this guy. Okay, this is going to involve u substitution. And I'll show a little bit of work on this. This one's going to be u substitution where u is the denominator. Technically, this is u substitution too, but it's not super necessary because du is equal to 1, and 1 is what we have, right? Okay, so do this in your head if you want to, but u is the denominator. The derivative of that is 2 dx. I don't want 2 dx, I want negative 1. So negative 1 dx. In order to get a negative 1, I had to divide by 2 and multiply by negative 1. So negative 1/2, we'll call it that. So what I'm really dealing with here is the integral from, actually this is u substitution with definite integration, which means I would have to sub 1 in here and 2 in here, and I'm not going to do that. I'm just not going to do it. Hang with me, you'll see. I really have the integral of, let's see, call it negative 1/2, and then, no, don't, yeah, you can call it negative 1/2. 1 over u and then du. Everything's accounted for. There's your u. Negative 1/2 du is negative 1 dx. It's all accounted for. This is going to give me negative 1/2 natural log of u, and then plus c. I'm not forgetting the c, but in a minute we're going to just switch it back and plug 1 and 2 in, which I can totally do because we'll have negative 1/2 natural log of 2x minus 1, which will never be negative because we're going to plug in positive 1 gives us a positive, positive 2 gives us a positive, so we're fine on that. So I'm ready to move on if you are. Here's what just happened. We integrated this using u substitution, and we got negative 1/2 natural log of 2x minus 1, and let's make it parentheses. It's just going to look a little nicer if we do, because like I said, it'll never be negative. And that goes from 1 to 2. Okay, we could do u substitution on this one as well. Not, just not. Because again, if I did, u would equal x plus 1, du equals 1 dx. It's ready to go. There's no tweaking to do. So plus natural log x plus 1, which will never be negative based on the numbers that we have to plug in. I have to substitute. Let me use proper mathematical language. There we go. So let's plug in some numbers, and we're going to keep going with this. I'm not going to have enough room down here. I might have to erase this beautiful thing that just took place over here, but not yet. So negative 1/2 natural log of 2 times 2 minus 1, so 3, minus negative 1/2 natural log of 2 times 1 minus 1, which is that. Okay, if you're looking ahead, you'll realize that this is about to go away because it's e to the 0 that would give me 1, but we'll keep driving this train. Plus natural log of 2 plus 1, so natural log of 3. Oh, neat. These two are very similar. And then plus natural log of 2. Okay? I'm going to pause here. I'm going to look through my work, make sure I've not made any glaring errors. And I have not I don't think I have. I think I'm good. I have made a mistake. I made a mistake. Notice it? Glad I stopped. Here it is. This plug in a 2 minus this plug in a 1. So far so good because that was minus a negative. Plus this plug in a 2 minus. Ooh, there we go. Be careful. You must be careful. I was looking back at the work that I had done previously when I had done this originally. Okay, that second term, I said this a minute ago, but this second term right here, let's mark it out in green. Natural log of 1 is 0. Anything to the 0 power is 1. Logs ask for exponents, and that one's gone. So let's just simplify our lives and leave it like that. If you want to leave your answer like that, you can. I do want to go a little bit further with this and bring my work over here. I'm going to use the properties of logarithms because if this was a multiple choice question, then you should skip it and come back to it because it takes way too long. Spend your time on the ones that you can do quickly and efficiently. But in this case, I would simplify this a little more because this may not show up as an answer. So I'm going to bring my work up here, and here it goes. This negative 1/2 is going to become an exponent on that 3. So natural log of 3 to the negative 1/2. And then plus natural log of 3 minus natural log of 2. This is the natural log of 1 over square root of 3 plus the natural log of 3 minus the natural log of 2. It's going to get fun. I love this stuff. And then what we're going to do is get this dot off the board, and we're going to multiply those two and divide by that one. Let's go ahead and multiply those two first. It'll be tricky if we do too much at once. Natural log of 3 divided by the square root of 3, and then minus the natural log of 2. 3 divided by the square root of 3 is the square root of 3. It makes sense, right? So like square root of 3 is the denominator and 3 is the numerator, but 3 is square root of 3 times square root of 3, and they'd cancel, so I'm left with the square root of 3. So this is the natural log of the square root of 3 minus the natural log of 2, which gives me the natural log of the square root of 3 over 2 as my final answer, and I think it's absolutely lovely. I'm enjoying it. All right, I'm going to double check.